What's up, what's up, what's up? Okay, so we are going to do another video here. Areas between curves. Let's jump right into it. Here's the formula right here. So, if we are trying to find this shaded green region, okay, this area between these two functions, f of x and g of x, bounded by the x values a and b, this is going to be our formula right here. It's just the definite integral from a to b of f of x minus g of x. Here's that same formula kind of written out in English as opposed to math notation. All right, the trickiest part here is going to be kind of figuring out what is the upper function and what is the lower function. Okay, so it's going to be very useful most of the time to have a graph to kind of reference. Okay, and when I say upper and lower function, I literally mean which one's on top and which one's on the bottom. Okay, so it's just the upper function minus the lower function, and you're just getting the definite integral of that from a to b, whatever your x values are of your region of interest. So let's kind of jump into some examples, but we're going to be using this formula right here for every single problem we do here. All right, so this first one, let's determine the area enclosed by x squared and y equals square root x. Okay, so once again, we're trying to get the area in green there. It's pretty clear that the square root x, that's going to be our upper function. And the x squared is going to be our lower function. Just looking at the graph we have right there. Okay, our limits of integration. Well, our x value here is 0, our x value here is 1. Okay, so setting up that definite integral, it's going to be from 0 to 1 of upper minus lower. So in this case, square root x minus x squared dx. Okay, after you have that set up, the hard part's over. All right, all we need to do now is just integrate. So it's from 0 to 1, x to the 1/2 minus x squared dx. Okay, so it's going to be x to the 3/2, 2/3, x to the 3/2 minus 1/3 x cubed. And I'm evaluating that from x equals 0 to x equals 1. So we're just evaluating a definite integral. We just need to plug in the numbers. So 2/3 times 1 to the 3/2 minus 1/3 times 1 cubed minus 2/3 times 0 to the 3/2 minus 1/3 times 0 cubed. This is all going to be 0. That's pretty helpful. This will just be 2/3 minus 1/3. 2/3 minus 1/3 equals 1/3. All right, the nice thing with these problems is that you don't need to worry about any kind of negatives. You should never get a negative area here, unlike with the net area problems. So if you get a negative answer, you've done something wrong. Okay, everything should be positive. You don't have to worry about kind of splitting things up as much. You should always get a positive value for your areas here. Okay, so let's do this example 2. So once again, it's going to be helpful to have this graph. This is just an incomplete graph of the two functions, obviously, but it kind of shows us the region we are interested in, shaded in green. It's clear that our upper function is the 4x plus 16. The lower function okay, and it's probably pretty clear from the graph what the 2 points of intersection is, but let's just kind of show how we can figure that out. All you would do, we're interested in the x values where these two functions intersect. All I'm going to do, and this is to find the limits of integration, is set the two functions equal to each other. So 2x squared plus 10 equals 4x plus 16. And then I'm just going to solve this. So I'll just bring everything over to the left and get a little quadratic. Let's factor it. So I'd factor out the 2. So it's going to end up being, we'll have 2 times x plus 1, x minus 3. So my values of x equals negative 1 and x equals 3, which matches up exactly what we see here. Okay, so that's just the solve for those limit of integrations, kind of the values of x that you want to integrate your function over. Now that we have those points of intersection, we can set up our definite integral. So it's from negative 1 to 3 of upper minus lower. So that's going to be 4x plus 16 minus 2x squared plus 10 dx. All right, so I'm going to do some cleanup here, kind of simplify what I have inside the integral before I start integrating. Can kind of save you some effort here. So, kind of the simplified integral there. I'll still have 4x, and then minus 2x squared, and then 16 minus 10 is plus 6. Now we can integrate. So it's going to be 2x squared minus 2/3 x cubed plus 6x. And we're evaluating this from x equals negative 1 to x equals 3. All right, so we just need to plug in those values here. So 2 times 3 squared minus 2/3 times 3 cubed plus 6 times 3 minus 2 times negative 1 squared minus 2/3 negative 1 cubed plus 6 times negative 1. All right, so over here we'll have 9 times 2, which is 18, 27 times negative 2/3, which is negative 18, 6 times 3, which is 18. So that's just going to be 18. And then minus over here we'll have 2 plus 2/3 minus 6. All right, so let's get some common denominator action here. I'll move my work up to this area. So we have 18 sorry about that, 18 minus 2 plus 2/3 minus 6. Let's get everything into thirds. So 18 is going to be 54 over 3 minus 6 over 3 plus 2 over 3 minus 18 over 3, which ends up getting us 54 over 3 minus negative 10 over 3. So 54 plus over 3 plus 10/3, we get 64 thirds. It's a lot of thirds. But there we go. All right. All right, last example here. We want to determine the area of the region enclosed by y equals sine x, y equals cosine x. Whoops, a little typo there. X equals pi over 2 and the y-axis. Okay, so the kind of the x equals pi over 2 and the y-axis portion, that's basically giving us our kind of outside limits of integration here. This one's going to be different than our previous examples because if you look at our green region and kind of what's making up the area we want to find, first of all, we see that there's kind of this split in the middle here, okay, at pi over 4, where the functions kind of intersect in the middle of our region, okay? And then we also notice here that the upper and lower functions flip in the middle of the problem. All right, so over here to the left of pi over 4, cosine is the upper function, sine's the lower function. To the right of that, to the right of pi over 4, now sine x is the upper function and cosine x is the lower function. Okay, so what we'll have to do is we'll deal with this very similarly how we dealt with kind of some area problems in the past, is we're going to have to set up two different integrals, one for each region. All right, still following that same pattern. All right, still doing the a and b of our limits of integration, those x values, and still doing upper function minus lower function. So the first integral to set up here would be 0 to pi over 4. And in that region, the 0 to pi over 4, the upper function is cosine. The lower function is sine. And then we'll have to add that with our second integral, which is going to be from pi over 4 to pi over 2. And that's going to be sine x minus cosine x. Because for that one, sine is the upper function. Okay, so let's work with this top one first. So to integrate that, it'll be sine x and then plus cosine x. And we'll evaluate that from 0 to pi over 4. And then for the other one, all right, so it is going to be negative cosine x minus sine x. And we're going to be evaluating that from pi over 4 to pi over 2. Okay, so let's plug in here. So plugging in pi over 4, so we'll have sine of pi over 4 plus cosine pi over 4 minus sine of 0 plus cosine of 0. So sine of pi over 4 and cosine of pi over 4 are both root 2 over 2. Minus sine of 0 is 0, cosine of 0 is 1. So root 2 over 2 plus root 2 over 2, that's just going to be root 2. So we'll just have root 2 minus 1 for that first integral. Let's do the second one here. So we'll have negative cosine of pi over 2 minus sine of pi over 2 minus negative cosine, whoops, I'll plug in need to plug in pi over 4 over here. So negative cosine of pi over 4 minus sine of pi over 4. Be careful because we have this term over here that's negative cosine of pi over 4 minus sine of pi over 4. Does not exactly match what we have up there, so you need to be careful. We know cosine of pi over 2 is 0. Sine of pi over 2 is 1, so it's 0 minus 1 minus, well, cosine of pi over 4 is root 2 over 2 minus sine pi over 4, so minus root 2 over 2. All right, so we have, where was I? Yeah, negative 1 minus minus negative root 2. Okay, so plus root 2. Okay, so adding kind of my answers together here, I have root 2 minus 1 and negative 1 plus root 2. So we'll have root 2 minus 1 plus negative 1 plus root 2. All right, so we have 2 root 2 minus 2. All right, you can leave it like that, or we can get a decimal approximation. 1 second. So the decimal approximation for 2 root 2 minus 2 would equal 0.828. Okay, so I prefer that exact form, but I know some people out there love the decimals. Let me write this a little bit more clearly. But there we go. Okay, so the main point here is that when you have breaks in your region, okay, you need to be very careful about which function is the upper and lower function, and break up the interval by all those points of the intersection, and then just add up each area separately. Okay, so basically this first one, that root 2 minus 1, that's the area for this region. The area for this region is negative 1 plus root 2. To get the total area, we just added them together, and that's how we got 2 root 2 minus 2.